everyone. So I'm not, and I know this is gonna sound like a theme. I'm not abandoning either of the previous ones of the previous series I had of data science from scratch and building apps. But we're starting something new because I took someone under my wing. I'm just gonna move my stuff over here. So I took someone under my wing recently, um, and they're very far behind. Let's put it that way. They're literally starting from zero, and so I created this. And for you guys, like you're seeing this now, and I'm like way past this episode. And hopefully, if things go right, a mix of both. Because I do want to be doing this and that one, and I feel like this is helpful for me, wherein I'm just reviewing and explaining things, more or less, with maybe some light Googling here and there. Yeah. So we're gonna just get into it. We're just gonna get into it. We're just gonna look up this book, Think Python, right? And it's a very simple book about trying to get people to not just learn Python, because learning the syntax, you can learn some basic things in boot camps. And if you go to like there's a lot of simple stuff out there, but more focusing on Python as a language, like, and Python from the eyes of a beginner, and teaching them not just Python code, but also to think right. At least that's the way this book was putting itself out. And what I really liked is everything is available on Colab. So you can just literally open this up and bingo bango, start running it. And that's what I'm gonna do. We're just gonna start this up. This first cell is really not much happening. Uh, it's just setting up the rest of the notebook. For some reason, import think Python, like probably some sort of testing suite or whatever. That's like the first cell. I'm not gonna read that out. I don't understand why this command enter. There you go. Okay, that thing was annoying me. So programming is a way of thinking. First goal of this book is to teach you how to program in Python, but learning to program means learning a new way to think. The second goal of this book is to help you think like a computer scientist. This way of thinking combines some of the best features of mathematics, engineering, and natural science. Like mathematicians, computer scientists use formal languages to denote ideas, specifically computations. Like engineers, they design things, assembling components into systems and evaluating trade-offs among alternatives. Like scientists, they observe the behavior of complex systems, form hypotheses, and test predictions. Now, I'll be honest, this is like, I read this because I was trying to find like materials for this person that they could consume, and I saw this and I read this. And I'm like, oh, I love it. They sold it to me. So, oh, thank you. Thank you. So, sorry about that. I was really hungry, and I just had some food handed to me, so I ate a little bit of it. It's still sitting here. Let me see if this shows up in the camera. Yeah. So I literally had a bite and continued recording. But I was super hungry, and I just needed that. And honestly, most of these books have these kinds of intros where it's like, oh, we're going to teach you how to learn and how to think and blah, blah, blah. And that's somewhat true, but honestly, a lot of this also has to come from you. And getting a good mentor makes a huge difference, right? So sometimes people, they have the will and they may even have the mind for it, but they just are getting terrible advice from everyone in their environment, right? Just because the people in their environment are actually dealing with the same struggles they are. So they're basically seeing the same type of solutions that you are, right? Or have that kind of exposure. Uh, so, anyways, so it's just a very basic intro in this. It just talks about arithmetic operators, right? So plus is plus, minus is minus, star is multiplication, forward slash is division. So regarding division, it'll pretty much always run as a float, right? Whenever you do division, you can do integer division instead, which would give you a integer, but remember it's floor division, so it's gonna always round down, which may not be the case that you always want to do that, right? Pretty straightforward stuff over here, nothing crazy, just talking about basic arithmetic operations and how to, and these are the little code pieces to do them in Python. A note here, because I am going to try and aim this at people who want to learn programming, though I'm not going to get too much. Some people who want to get into programming don't even know the math, so division, multiplication, things like that, do look those up. But here basically is your first interaction with the concept of types. So here, as you can see, where I did 84 divided by 2, I got 42.0. But if I ran any of these other cells, you're seeing a integer. You're not seeing the dot something else, not as a decimal, right? And the reason this is 42.0 and these is not, because these can be evaluated to exact integers, but Python knows that, divisions can usually yield some sort of decimal or fraction, so it automatically returns as a float, right? And one of the ways to take care of that is to do floor division instead, which gives you an integer over here. So that would be 2 forward slashes. That gives you an integer, right? But remember that always rounds down. For quick reference, the regular rounding rules are if it's 5 or higher, it rounds up to the next. Or if it's less than 5, it rounds down, right? Now that's like the common rules, but I've heard some small variations and it's fine. And there is something, I don't remember exactly, but some sort of weirdness to the order of operations in Python arithmetic. So the star is for exponentiation, so 7 raised to the power of 2, 7 times 7, that will be 49, I believe. Yep, it's 49. So here's an interesting thing where, because I made this mistake in a very public way earlier in this channel. So this caret symbol is actually the bitwise operator, not the exponentiation operator as I thought, which is apparently a common mistake because it's the caret operator, this little upward facing arrow, is the symbol for exponentiation in many other languages. And also if you go into Google and just type it like that, it'll automatically infer that it's that you're exponentiating something. I am curious, I'm going to do a little bit of Googling here. I do want to know exactly what bitwise operators are. What exactly do bitwise operators do? Because I know they operate on literally the bits, and I don't remember exactly how that works. Sorry, I wanted to eat some more. So XOR is exclusive OR. I get the binary? I'm going representation. Okay, I'm just gonna do binary calculator. I'm gonna do this twice. So 7 is 0, 111, and 5 is 0, 101. So basically what I'm trying to do here, to give you guys some context, so over here, 7 caret operator 2 is 7 exclusive or bitwise operator 2, right? And I believe the answer is 5. Yeah, it's 5. So I'm just trying to see how we get to that. So the exclusive OR is basically if both are different, then it returns 1 or it's 0. So 5 is 0, 1, 0, 1. So it'll be 0, 0, because it's both of them start with 0, 1, 0, 1. And then 1 and 0, and then 0, 1, 0, 1, 0, 111. You know what? This is easier if I write it out. Oh. I'm just gonna pause the recording before I open that up, just in case. There you go. I didn't want to leak some personal stuff. Hopefully, I still didn't. I will double check that. Actually, I'm just gonna double check that now because now I'm nervous about it. All right, we are all good. So, binary test. That's just what I'm gonna call the note. So 7 is 0, 111. 0, 111. Wait, it's 7, 2, isn't it? Yeah, 7, 2. So what I actually want to know is what is 2 is binary. So that's just 1, 0. 2 is 0, 0, 1, 0. Right? So exclusive OR means that it'll be the same, it'll be 0 if both, it'll be 1 if both digits are different, correct? Returns 1 if the two corresponding bits are different. Okay, so 0, 0, so that'll be 0. Then 1, 0, that'll be 1. Then it'll be 0, 1, 0, 0. Just gonna put that 1, 1, that'll be 0. And then 1, 0 will be 1 again. And 0, 1, 0, 1 is indeed 5. I believe. Where is it? There you go, 5. 0, 1, 0, 1 is 5. So that's why this operation here leads to 5. So, fine. So this is just a note about order of expressions. So basic PEMDAS here. 6 plus 6 raised to the power of 2. 6 raised to the power of 2 is going to get evaluated first. I know from a previous episode that there is some funkiness in how Python does order of operations. So I'm just going to Google that. Python order of operations arithmetic. Okay. Okay, so this is the valid point that I'm trying to make. So PEMDAS, okay, so this actually explains this super well, actually. Um, PEMDAS is about argument grouping, essentially. And in math, once you have the groupings right, so parentheses, that's your highest level group, then exponents, they'll be a group within themselves. Then multiplication, division, they're a group within themselves, and then addition, subtraction. And then after that, whatever order you evaluate in, like if you add then subtract or subtract then add, it doesn't matter, but as long as you respect those groupings, it'll work, right? Order of operations in Python can have different effects, right? Because even though PEMDAS is followed with just pure arithmetic, if that arithmetic is happening with function calls, like I'm gonna go there and fetch this and fetch that and that and that, it's gonna be evaluated left to right. So even though this a plus b plus in parentheses c times d, it's still going to evaluate, it's going to go left to right, it's going to evaluate a first, then b first, and then it'll evaluate c and d because they need to be evaluated separately before multiplying together, and then evaluate the plus, even though the parentheses and the multiplication both take precedence over adding b, over adding a and b together, right? So that's a funky thing with Python and argument structures. Order of operations, not argument structures. Argument structures, what is that? That doesn't even make sense. That's a random word. So that's what these expressions are. Arithmetic functions, round, ABS for absolute, ABS negative 42, ABS 42. Either way, they're just a function call, right? So I think this section is someone's introduction to what a function is, which is essentially a reusable piece of code. So someone wrote the function round, which is somewhere, right? And you can write your own functions as well, something like def round, take some variable b, print b, return b plus 1. Let's say that. It's a really terrible function. I don't know why you would call it round. It doesn't make sense. But you can create your own functions. And now once I've created this function, I can pass in any value to b, right? Any integer, at least in this case, and it'll work. If I throw in a string, I think it'll go a little haywire, but whatever. So this is, now that you have this function, the way you call it would be something like this, round pass something, right? So when you write out a function name and then put the parentheses around it, that's how you write this out. This is a terrible video, I feel. Like, I'm just like going super basic, and I feel like for most people this is, I don't need to explain what a function call is. Yeah, I'm super hungry and super tired. I think this video is just going to go into the archives. I don't think this one's getting released, guys. Maybe I will. I don't know. You know what? I'm just going to keep reading this and just explaining and talking over it and just Googling things because, yeah. And I hope it inspires whoever's here to really pick this up. I'm not going to go super basics, but basically, yeah, to finish explaining what I was trying to say is round is a function, and the way you call a function is you write the function name and you put the parentheses, right? And that's all you need to do if the function takes no arguments. And if it takes arguments in the parentheses, you pass it arguments. as you do here. I gave it round 42.6. I'm going to run this. Gives me 43, right? And this is the proper rounding rules instead of the floor division. Absolute ABS, that gives me the absolute value. Absolute value of 42 is 42. Absolute value of negative 42 is also 42, right? You are essentially calling the function. That's all that matters here. This is a line over here that I had read earlier. So one thing that was interesting here to me is I don't know what this magic is, this Jupyter magic. So I'm going to Google this Jupyter magic. Because essentially the cell itself is just about showcasing what syntax errors are, right? You can't call a function without the parentheses. This doesn't make sense, and the space either, right? Even if I do this, that's still not going to work. It could be interpreted as a variable, so that could lead to some other bug. The term expect can refer to different concepts depending on the context. Okay. Jupyter magic. I started reading that. I'm like, why? Provided by the accept exception extension, this extension allows users to annotate cells in the Jupyter notebooks where they anticipate any exception. When a call the accept exception intercepts the traceback generated by the expected exception and displays it within the notebook rather than halting execution or presenting a standard error message that might be less informative in the specific context. This is particularly useful for demonstrating. Okay, so it's essentially just pretty printing the traceback somehow. That's what I thought it was, but I just didn't care enough because I'm like, I don't really use Jupyter much anymore. I mean, I do. Actually, that's not fair, but yeah. It's mostly for some super basic exploration before I move on. So strings, that's another data type other than integers and floats. In Python, you can write them with the single quotes or with the double quotes. If you have a single quote within a double quote, it's fine. But you can't have a double quote within a single quote. So it's a small, let's say world, just to finish that because it's weird for me to not have that finished. Even though there's an extra single quote over here with it apostrophe or single quote s, it's fine because I'm using double quotes, even though I can wrap strings in single quotes. So to showcase you, if I was to wrap this in single quotes, it's gonna throw me an error. It's like, what's going on? This is a string and this is what are you doing to me? Like, it just doesn't work, right? So if you expect single quotes within your string, you're going to want to use double quotes. And generally speaking, if you've been seeing any of my previous episodes, you know that most formatters usually enforce double quotes. Strings can also contain spaces, punctuation, and digits. Yes, so a string can basically have almost any character. There's a concept of encoding and how UTF-8 encoding works, which allows for almost every language and emojis and stuff like that. But I'm not going to get into that. So you can essentially have any character in a string. And you can add strings together, which is concatenates them, right? So concatenate to link things together in a chain or a series. So literally just put them together, right? So when you add strings together, it concatenates them. So comma space plus it's a small plus world gives you it's a small world. Okay, so you can use it's weird, but you can use certain arithmetic operators and it can be inferred to do other things based on the type that the operators receive, right? So spam comma space times 4, that will just repeat spam 4 times. See, spam. Len spam. So len is just a generic function that allows you to get the length of things. And with the case of strings, it just gives you the length of the string, right? It's that simple. Len is more complicated than that, and there's a whole thing about dunder and like magic functions in Python. Or we're not even getting into that. I actually don't even know if they're called magic functions. Um, I remember that backticks are not valid quotes for strings, and neither is the inverted apostrophe, like the smart quotes. I don't know where they're from. I feel like they're a Mac thing, but I'm not sure. And then values and types. So far, we've seen three kinds of values. 2 is an integer, 42 is a floating point number, and hello is a string, right? So that's essentially the data types we've gone through. And with the type function, you can pass it anything and it'll give you the type. So type of 2 is an int, type of 42.0 is a float, type of hello world is a string, str, right? Pretty simple, pretty straightforward. Now, that is the type, but there can be utilized as functions as well, in a way. Int, float, and str specifically. The types int, float, and str can be used as functions. For example, int can take a floating point number and convert it to an integer. Does it round it correctly though? No, it doesn't. So if you just do int, it'll do the same as integer division earlier and just gets you the number. If you do int and then pass it a float, right? So you can essentially, this is what is known as type coercion, and this is something that can that will become a complicated, can become a complicated topic. Honestly, everything can become like, everything I'm reading here, I'm like, oh, well, there's this, and then there's this also, and there's so many other things about this. I'm trying my damnedest to not go too far down rabbit holes and try and keep this broad and get through this. So integer 42.9, we'll do floor division and just get you the integer. And the reason you can use these types as functions, well, this is the whole concept of classes and stuff like that. We'll get into that later in this book. But essentially, this is important for type coercion. You want to be able to coerce one type into another type, and you need to be aware of how that mechanism works, because it may not work how you expect it. Like right now, int 42.9 will create 42, which is always rounding down, right? And if you actually wanted to have the rounded version of that, you would go and use the round arithmetic function that we were exposed to earlier, right? You would use round 42.4 or 42.6, which will give you the actual integer rounded in the appropriate fashion, right? You only want to use like int coercions for some other weird stuff. You can use it for other kind of stuff, right? Honestly, string something is usually the most helpful because everything can be turned into a string, or almost everything. So yeah, similarly as we coerced an int, we can coerce into a float. So 126, once again, this is a string because it's wrapped in quotes. It's trying to explain to you that this is actually a string, even though for a human being 126 is a number, or 126 is a number. It obviously is, right? But as far as computers go, it's wrapped in quotes, so it's a string, right? So it's not going to do any arithmetic operations on it. So if you do type of 126 with the quotes, you get string, which makes sense. And if you try to actually divide it, it won't work, because it's like, dude, you're giving me a string and an integer. How am I going to divide these two things? The string could be anything. It could be it could be a number, sure, but it's also could be hello world or whatever. I can't take a guess on what this string is. It's a string. Don't like be specific, right? And this is the thing with computer languages. They're highly specific languages, and they talk a little bit about this later on in this chapter, so I'm going to get to that in a moment. Now, with type coercion though, you can use int 126 and it will work, right? Because using that as a function, it will actually, like, Python won't do it, but this function which Python provides will do it, right? And then you can divide by 3, because when you pass it into this function int, you're actually taking the string and converting it into an integer, which then you can do arithmetic operations on. Same thing with float. You can do this over here and it'll be totally fine, right? A note on large numbers, if you separate things with commas, Python and commas are usually reserved for separating lists of things. So 1 comma 0 0 0 comma 0 0 0, that's not interpreted as a million by Python. That's actually interpreted as, 1 0 0, like just three different integers, right? And if you want to do that, you can use underscores and just to make it more readable if you're using big numbers in your code for some reason. So this little bit over here gets to what I was saying earlier and is great. I'm just going to read it out and explain it at the same time. And it's genuinely great and very valuable in that it's really outlining the differences between our languages and programming languages, right? In that it's essentially syntax at the end of the day. Everything is syntax, right? It's just the rules of how different languages work. And the difference between natural languages is that, and formal languages, and one of the biggest ones, honestly, is ambiguity. In that natural languages are filled with ambiguity. There's like 5 different words that mean the same thing. In fact, there's a word for words that mean the same thing. It's synonym, right? And then there's antonyms as well. I forget what an antonym is. And essentially that's intentional, right? Like you might have come across a Nazi, like a grammar Nazi, and they might have corrected you very aggressively about something. But honestly, in English, there's a lot of, and not just English, in any language, there's always a lot of ambiguity. And really, we pick things up by context, like what is someone's tone like, what were the other words they were saying around this word, etc., etc. A lot of things are picked up that way, and that doesn't work with formal languages. Mathematics is another formal language, right? It's very specific, right? And hence there's little to no redundancy in coding languages, right? This thing means this thing basically always, right? And if it can mean multiple things in different contexts, there's a very specific reason for that, right? Like, for example, with the additions we saw earlier, there is actually, when you define Python classes or operators or whatever, there are specific functions called um, underscore underscore eq underscore underscore, which is a magic function, which if you write that function, then you can compare whether or not this function is equal to this instance of some variable of some type is equal to another type, right? And the reason that's complicated is because you can create your own types, right? We haven't gotten to that yet, but you can, right? So, and it's also very literal, right? Everything is important, which means like small syntactic mistakes can lead to some big issues, right? So this is a very cool and very important distinction to make between formal languages and natural languages, and that computer programming languages and mathematics are formal languages. They're not natural languages, right? Debugging. So this I'm not really going to get into. Essentially, errors will happen and you need to engage in the process of finding them and fixing them. Let me actually read. Preparing for these reactions might help you deal with them. One approach to think of the computer as an employee with certain strengths like speed and precision and particular weaknesses like lack of empathy and inability to grasp the big picture. Your job is to be a good manager. Okay, yeah, so this is just talking about debugging and how frustrating debugging can be, and like that's part of the learning process, and that's very true. It is very much part of the learning process. Arithmetic so this is just glossary of all the terms in this thing. This is a really well written book, I think, personally. Here are some exercises. Just do that, run before exercises. You might wonder what round does if a number ends. I'm honestly not going to do any of these exercises. This is just like, okay, maybe I'll do this one. Alright, fine. You might wonder what round does if a number ends in 0. Oh, and there's some topics I could look up. How so? Yeah, I already did this. Round function. Yeah. So these are good questions to ask. It's weird. It's saying to like ask it to a virtual assistant, but all of these are easy Googles, honestly. Or even Stack Overflow questions. But virtual assistant is one way, and honestly, at the level of these questions are so low that a virtual assistant like an AI can answer these questions with decent level of detail. But whether or not that level of detail is something you can understand is a whole different thing. So it's a whole bit of difficulty there. Oh my god, what is this? Why is it 0.5 rounding Python? I'm just gonna Google this. What is this? Uses round half to even or bankers rounding when the fractional part of a number is exactly 0.5. This means, oh, I've looked this up. So just whenever it's 0.5, it rounds to the nearest even number instead. So 3.5 rounds to 4. Why is that the default? That's so stupid. Bankers rounding is dumb. But yeah, that's the default. So that's the explanation of this question here. You learn something every day, right? Just reading these extra. And some basic like throw in some errors, see what happens kind of thing. Okay, so these are just some super simple arithmetic coding exercises. This is more just thinking and then the type of ABS, that should be a type callable, yeah? Just gonna do type ABS. Yeah, built-in function or method. Yeah, so that's what I thought. What if I do type? Yeah. It's good I'm reading this is for someone else. It's gonna help me like actually be on them. All right, this is chapter 1. Somewhat longish video, I guess. I don't know. I'm gonna end this right now, and we'll do chapter 2 tomorrow, probably. All right, take care, everyone. Bye bye.